Right. Okay, so we have a number of apologies for the meeting today. That includes Herbert, Gemma, Arthur, Fatima, Mervyn, and Omar. I don't think I've got any other apologies yet. And we have a welcome to Susanna Martinez. Is she on the call, Matt? Can you see? I can't hear you, Matt.
No.
But it doesn't look like you're muted either. And we also have a welcome to Herbert. Susanna is someone who actually has expertise on physiology of fixation, which we thought might be useful for this meeting. Oh, and there's Ruth. And Herbert's a clinician with an interest in eye movement recordings as well. So that will also be very useful.
Can I check? Can you hear me now?
Yes.
Good.
Okay, Matt, yeah. Okay, I think Susanna was planning on joining the meeting, but maybe we'll catch her up. Okay, so we're now on to minutes and actions from the previous meeting. So everyone who was at the meeting, were you happy with the content of the minutes? I didn't get any. Yeah, I can see a lot of nods. And then there were a lot of action points that we should probably run through quickly. So a couple of them for me. So first one, incorporate agreed revisions and definitions, revisions to definition and purpose section of the guidelines that we've been working on. So I have, I think, emailed everyone the document where I've incorporated as many of the changes that we suggested, and we're still working on this. So this is kind of still a work in progress. And I also had the job to write some sort of paragraph about physiological origins. So I did send that around. Now, I know it only came through yesterday afternoon, but that is what I've come up with, trying to get that balance of not writing a whole essay, but enough of a like introductory paragraph for people doing fixational assessments. Bear in mind, we're targeting clinicians who might not necessarily have specific expertise. It is quite tricky to write a short paragraph on it. I think you can see everyone is actually reading it now, so I'll give everyone a minute or two to do. That is something we can tweak, but it's just something to put in there. Any thoughts?
I think that's a fair sort of basic description of it. I know there are obviously new ideas as to what the purpose of the drift is in terms of active enhancement of vision and so on, but we don't necessarily need to get into that for this because this is a clinical application.
Okay.
Yeah, agree. Brief is good for this document.
Okay.
I think this is where Susanna Martinez Conde will be able to contribute, because this is her, again, this is why we brought her on board.
Okay.
She knows physiology inside out.
Yeah, so we could just send this on to her if she's not able to join the meeting, and just give her the context that we want a brief, simple introduction to the physiology of ocular fixation for the purpose of a clinical guideline. Okay, and then if we go back to the next action points, Larry and Fiona had a big job, and you did do a good job on that. So I think we have a separate point in this meeting for you to go through the literature, unless you want to do it now, and then or do we want to go through all of the action points first and then come back to it?
Maybe Fiona did the vast amount of that, so she should probably be the spokesperson, but we did have several iterations on it.
Okay.
Yeah, that's right. And just to let you know, I need to leave maybe about 15 minutes early. So I'm
same here.
Yeah.
Okay. So everyone has to leave before the hour is up. Okay. Running through the next few minutes, action points. So I've done the action for removing, simplifying the population list in clinical applications. Matt, you had action to define approach for referencing separate ISCET guidance on normative data.
Yeah, so I you can hear me, yeah. In the last main ISET meeting, I showed a very rough structure for how the standards could look in terms of how they relate to one another. I can bring that up now. It's a single slide.
Yeah.
Should I do that? Yeah.
Yeah, if you want to do that, I shall stop sharing my screen.
Okay, and there it is. I can then choose the right window. Okay, hopefully you see a full screen slide. So this is very rough outline. It is not meant to be a definitive thing, but it's just showing how these things can relate to one another. So hopefully you can see my screen, which has got the two protocols we're working on now, one of which is kind of a core eye movement class type of test fixation. And then, of course, after we've done that, we're working on the nystagmus, which is both a type of eye movement and also a disorder or a series of disorders. So with regards to how this relates to the, it was the reference data sets, wasn't it? I've forgotten now what the specific point we're trying to link it into. So that on bottom left here, we've got the general protocol. So these would apply to all of the ISET tests. So, you know, how do you pre-process the data? In a lot of cases, that's going to be common across different types of eye movement data. How should the data be stored in terms of file formats, and then reference data sets, which is what was also sometimes known as normative data sets. And so some protocol for actually being able to record and collect this data and then create it into some kind of database. We would need to have a separate set of protocols for that as well. So hopefully this gives some sense of how these things may end up relating to one another. This is not meant to be exhaustive lists, nor is it meant to be definitive. It's just a first draft at how this might work. Does anyone have any questions about that?
Matt, would we have a sort of other category for the top box where for some, say, rarer disorders, some of the tests that are used in here would also be applied?
I see what you mean. Yeah. So maybe, do you mean if there was another condition that used the same tests as,
well, like
say,
the metabolic? I'm thinking of the metabolic storage disorders, for instance, Niemann-Pick, Gaucher, Tay-Sachs, where a lot of the tests would be the same, but like directionality is different between them.
Yeah, and I'm not an expert on those disorders, so I don't know how they would fit in. Perhaps it's worth defining a separate set of protocols for them, or if it's going to end up sprawling into this endless list of different different tests, and they are essentially the same test as another set, then I guess it can fall under that same bracket.
Yeah, I was thinking maybe other neurological disorders, or just somewhere to get other conditions that aren't common enough to get their own box.
Sure.
Okay. Jay's got his hand up, so I'm pretty sure I know what he's going to say, but go on. Jay?
Yeah. No, I'm just going to say it's really nice to see this on the screen. I've never quite got my head around this before. I guess, sorry for my ignorance, I wasn't at the last meeting. The idea here is that we've got these general protocols, we've got the core tests, and then the ones in the top box for specific disorders are basically drawing on those and saying, these ones are relevant here, this is the little tweak, but we're keeping those relatively short and simple. Is that the mantra?
So again, I don't want to dictate how this is done. This is just to get something down on the screen. But yes, that's what I'm thinking, is that, you know, you've got these 5 basic tests, VOR and so on, maybe there as well. And then, for example, in the nystagmus, when we say, right, we take the fixation test, but we perform it for this duration at these gaze angles. And then in certain tests, you might need to do a bit of saccade testing and a bit of pursuit testing. And so, the core tests are, like it sounds like they are the core tests. And then we can draw upon those for different diseases, I think.
And then for
maybe better structure too.
Yeah, and then for those core tests, are we doing what we talked about right at the start, was this is the perfect, this is the next option, this is the next option, working our way down to give people options.
Absolutely.
I think that's really good. This now makes sense in my brain. Thank you.
Yeah. And I'd say we'll never be able to do an exhaustive list of standards for specific diseases and things. I think it would be useful to say these are examples of applications, perhaps, and it could be expanded out potentially to other conditions, because we cannot be exhaustive. Otherwise that box will just keep expanding.
Yeah, but if they're relatively simple,
Yeah.
that wouldn't be the end of the world. I think the benefit here is you're not repeating everything you're saying about how to do saccades and fixation pursuit in each one, which is the pain, right?
Yeah.
Yeah, cool. Thank you.
Amanda?
Two questions. I'm wondering whether in that top box they can have, similar to how Larry sort of said, neurological other. There's a bunch of those that kind of go together, and I'm also wondering in core test whether or not we will get into some of the visual search, visual scan path type stuff as well, because I think that's the other piece that's kind of missing there. Like everything we've talked about at the moment is kind of those basic eye movement tests.
Yep, I'll add visual search to that bottom box there. But I said at some point we probably should get the whole group together and actually work this through from first principles. I don't want this to necessarily be, definitive in any way, and we can maybe do it from afresh. But yes, for now I'll add that into this group. I should also just add as well that I think before we can actually use the nystagmus protocol, obviously you need to have the fixation protocol in place, but we'd also need to have these three on the bottom left as well. So that, until we can actually start doing anything, you need to know how we can store the data and process and so on. So those are the ones that would be necessary to do anything.
Yeah. Fiona?
Yeah, just two short points. So the first one is just to consider whether balance disorders and vestibular tests are included in here somewhere. And also just to note that like nystagmus could be considered a fixation disorder. Mm-hmm. Everything else in the top box is a diagnosis, whereas nystagmus is a type of eye movement. So before things get complex and a bit confused between the two, which reminds me of some of the difficulties we had, Matt, going through the questionnaire as well, where we were trying to separate eye movements from diagnoses. That maybe nystagmus could be considered a fixation disorder, and maybe some balance or vestibular disorders, which are probably the longest used eye movement diagnostics clinically, might be included in the top box.
Yeah. Okay. I completely agree. The nystagmus kind of fits in this weird thing. It is both a type of eye movement, but it's also a group of disorders as well. There's things attached to that. So I'm glad we started with this because it means we're getting the most kind of, wrangling with the most complex one to define at the first outset. I'll make a note that we would want to try and look into vestibular things as well. But again, I say this is just meant to be a quick first draft.
Can I just say, sorry, Helena, I was going to say something similar along the lines of that top box at the moment is diagnoses rather than presentations. And again, I guess you need to decide whether you want to go down the route of presentations or not. When people are deciding what test to do, you often don't already know it's a Lewy body dementia. Do you know what I mean? It's because you've got kind of two options there, haven't you? That's partly why nystagmus stands out a bit oddly, because actually it's a presentation. I don't know if that's worth a thought.
No, that's a really good point, because you're right. You don't say, right, I'm going to run the dementia with Lewy bodies protocol until you know that that's what we've got.
Yeah.
So, absolutely.
It's a differential, but yeah.
So okay, that's a very good point. Maybe we need to rethink that top box entirely then.
I've got this problem. What do I need to do to pull out the potential condition?
Yeah, absolutely. Okay. Presentations, not diagnoses. Got it. Thank you. This is really helpful. So I guess we'll stop it there, not to take up the whole time on this, but that's a really good first pass on that. Thank you.
Okay, so if we come back to right, so that was Matt's, and then the next two action points for Rebecca and I, we did that table of protocol parameters, and then we allocated the evidence gathering tasks for each parameter to pairs of people, and majority of people did get back. And then didn't quite get to the pediatric compliance acknowledgement statement, so I will get to that. I was still pulling together all of the evidence that was sent in. And then we are now moving on to, if I go back to the agenda, the actual fixation guideline development. So at this point, shall we go over technology requirements? So that will go to Fiona because she did an amazing paper that I could see that she's been working on with Larry.
Yeah, that's right. Larry has given great feedback and content, including, a plot for the draft. So I could share my screen potentially. I don't have anything particularly new since the last time we briefly talked about this. What I was hoping was that maybe one or two others would come in and cast some eyes over what we've done from the clinical side before sharing it publicly. But I can show you what we have. 1 second.
Yeah.
So do you see my screen?
Yeah.
Okay, so maybe I can actually make this full screen. Yeah, so what we've done is go through existing papers, guidelines, and so on that don't necessarily talk explicitly about nystagmus, but talk about measures which are highly relevant for the different measures of nystagmus 2. So we've gone through the signal processing foundations, differential problem. I've included this list of contents for now so that anyone coming in can orient. And then going into sampling rate requirements by eye movement type, where some of the requirements that have been explicated for saccades and microsaccades and smooth pursuit are relevant to nystagmus, and it could be worth looking at these studies to see, is there, to avoid repeating work that's already been done. And then just looking over clinical protocols for saccadic assessment and how they might be relevant, looking at spatial and also temporal precision, both being equally important, and the resolution and instruments and so on. And there we talk a little bit about how a lot of the existing literature was created for quite different hardware, going back to referencing the DPI and EOG recordings and so on, which are quite different to today's head-mounted trackers. So you can see I've covered the existing Barani Society standards also, and then finished off with the applicability of existing requirements documents to nystagmus, and a table showing quantitative thresholds. And this summary table is really where it would be great to get some input, because, we may have missed something that's quite relevant here. I did a systematic search, but it's very possible that just due to terminology or something else that I've missed something that's relevant. And then we conclude really with a strong statement saying that while we can extract these technical requirements, that it really depends on whether a qualitative or a quantitative assessment is wanted, and that at the end of the day, we leave up to a clinical decision making a lot of what's really required, so that it's clear that this isn't a very black and white set of requirements. So the review is pretty comprehensive. This is Larry's figure that we have here showing how sample rate is clipping peaks and troughs of the nystagmus profile. And probably the most important is the table to show what's covered, which is this one. I might need to download this to turn it around. 1 sec. So here we have this kind of summary table, just citing the literature that we cover in terms of the minimum sample rate that's quoted, and which measures were taken, and any additional requirements that are mentioned, and giving the primary source there. So I don't know if it's worth going into very much more detail today, because I think if anyone is willing to go in and review it, then we can just add them to the overleaf, where they can take their time going through, but that's essentially what we've worked on so far. And the conclusions are probably worth looking at briefly too. So this last paragraph stating that experienced clinicians have legitimately operated at lower specifications for qualitative assessments, and that the group, so this is why I would like more eyes on it, because I'm speaking for the group here, so has chosen not to resolve it by issuing separate specifications for research and clinical contexts, but that the decision is pragmatic and just finishing with the specifications in the review should be understood as the minimum required to support the full range of quantitative nystagmus measurements. Where a clinical purpose is demonstrably qualitative, the applications of these thresholds requires the exercise of clinical judgment. So I don't know if that covers everything, or Larry, if you have anything further to share.
I think just regarding that last section, that I think the discussion was, if you're only doing that's an unfortunate term for what I do a lot of, doing a qualitative assessment, you're not harmed by having more stringent quantitative specifications. You'll be getting very good quality data, even if you don't actually need it. So I think it makes sense, and sometimes the same facility, you might start by doing a qualitative assessment, but you might then want to quantify the data. So I think using the stricter standard as the baseline makes sense, even though most of the recordings I do for ophthalmologists wouldn't meet that standard. I would not be harmed if the equipment did. So I think that was kind of the idea for keeping one strict level of performance, even if it's not always necessary.
Right.
Jay?
Sorry.
Yeah, Jay, go on. Yeah.
Sorry, yeah, no, I was just going to say, as long as that doesn't come at the cost of time or likelihood of actually being able to do the thing, I think we've got to be a bit careful about that. I understand the idea of actually if we test everything and only use a little tiny bit of it, we've got it, we've not lost anything. But if that means a protocol which is significantly longer, harder to do, requiring different equipment, etc., we've got to be slightly careful from the clinical angle.
I meant the equipment, not the protocol. In other words, the protocol I might do for research might be quite different than the protocol I would do for clinical evaluation, but it would be done on the same equipment.
Okay, and we don't run the risk there of people, being able to get a more simple tracker that could be of some use clinically, but they don't, because we say everyone needs to have a fantastic one.
Yes.
Is that that's not a risk?
Well, I think it would be, but I think that's where we have the minimum standards in there somewhere for performance, beyond which they wouldn't be suitable. That was the reason I put the different sampling rates in, to show the distortions that would occur. Because there's at ARVO this year, there was a whole new set of VR headset-based all-in-one ophthalmic labs, basically. They will do eye movements, they will do fields, they will do EOG, and they're pretty vague in some cases about performance. So I think we do want to make sure that we have a minimum standard that is explicit, so that these wonderful full of bells and whistles systems actually could do the tests they claim to. So I do think that we do need to be careful as new stuff comes into the market, that there is a baseline of performance that's needed.
Yeah. Okay. Yeah. I'm just thinking about that. That's there's two different things there, though, right? If it's to do a baseline for kit to do something useful in the clinic, might be different to the baseline for kit to be able to do everything, as we said a minute ago, and then only just use some of the data. But so I don't understand the kit differences enough to know. I'm just highlighting the point. Is that, or raising the question, is that an issue? Because if a VR headset really doesn't have quite what we think it should have, but it can tell the two things that a clinician actually wants to know, you might argue that still has some utility.
Well, I'm concerned. I'm not sure about the headsets based on Tobii technology, but the Tobii glasses, for instance, operate with a variable frame rate, which is fine if you're looking at gaze. But if you're looking at parameters that are time-based, that's going to really distort the results. So that is a hardware limit. And because some of those eye trackers are very cheap, I could imagine a clinician buying one and not actually appreciating that the nature of the variability is going to distort the result.
Got it.
Yeah,
Yeah,
and
thanks.
if I could just add as well that we've tried to deal with that quite explicitly in the paper. So we do talk about how different measurements require different data quality, and kind of pointed out that the data quality constraints on the system are really based on whichever measure it is you're trying to take, and to give guidance explicitly on that as well.
Got it. Thank you.
Yeah, this is where I need to ask any people involved in clinical eye tracking, do you want to volunteer to cast an eye over this and sense check it? Well, I know Matt's hand is up. I think Matt has already been volunteered.
I think Fiona's already sent it to me, actually, so I'll be looking at that later this week.
Yeah.
I wanted to just raise a point, though, that most clinicians at the moment do qualitative assessment of nystagmus, so looking at the waveform, and that's all. However, I guess we need to ask specifically everyone, but I think if the ISCET guidelines were more explicit and more readily available, then actually I think more clinicians would lean towards quantitative assessments. It's just at the moment it's very difficult to know how to do that, and so qualitative is what everyone does. So if we're thinking about hardware requirements for qualitative versus quantitative, yes, qualitative probably doesn't require quite as much, but I think that Ruth raised this point in the last meeting, that we should be aiming for something which is of a good standard, and actually once that is embedded and available, people might be more likely to use it. So we may see a move away from qualitative assessments once we have good guidelines in place.
Okay, Larry?
Yeah, I just want to follow on for that. I think that would actually be a good thing, but the issue isn't so much the hardware as the software, the doing of the analysis, because right now automating quantitative assessments, say, of infantile nystagmus is difficult. Maybe with the application of AI, something I've been arguing for since the mid 80s, it might become feasible. But right now, if you want to calculate foveation durations, I don't believe you could do that reliably without human intervention, which really narrows the range of people who can do it. Probably most of them are on this in this meeting. So I think that's something which I think should be aimed for in the future. But implementing that will be a software issue, I think, not a hardware issue. We can get the data quality we need from the hardware now, but we don't have the software to make that universally available in the way we do for other electrophysiological tests.
Okay. Right, I think we need to move on, but that's fantastic work on the technology requirements. So we've had Matt volunteer. Let's see if anyone else clinically would like to volunteer to, I imagine it wouldn't take long to sense check it because they've done all the hard work. Everyone's a little bit intimidated by what they've seen, I think. Right, okay. Well, I'll take a look at it as well.
I'll do it.
Okay.
I'll do it. Yeah.
Yeah, we just need, just so that it is sense checked. Right.
Could you maybe send me which email address you want to use for Overleaf, and I'll just join you in. Anyone who's willing. I didn't catch who volunteered there, apart from Helena.
Oh, it's Rebecca.
Okay. Andreas's hand went up. Is that And Andreas, fantastic. We've got a few volunteers now.
Thank you.
Right, so back to my screen now. So
I can do
now
it as well.
Okay.
Sorry.
Who was that? Sorry, I was just sharing screen. You want to shout out your name so that Fiona knows who to add?
You can just write your email address for Overleaf into the chat, and I'll join you up if that works.
Okay, so now we're moving on to a review of the consolidated evidence-based search that we were assigned ahead of this meeting. So can everyone see the Excel? I tried to put it all into the Excel sheet. So I thought maybe if we work through it and we see how far we get and decide what we agree on and what actually needs a consensus exercise, I think that would be a good first step. And we'll go from there, because I think as we did this exercise, a few interesting points were raised as to how this should be done. So I think the first one was patient positioning, distance from screen, and head stabilization. So that was Matt.
And Siwan, yeah, we did this one together.
Yeah. So I tried I had to give you a separate tab for your evidence, and then I realized the image didn't come through of your bar chart. But if you want to briefly talk to it.
Yep, I'm trying to bring up the email I sent to you so I can actually refer to that one. Yeah, so in terms of screen distance, it varies a lot. We've seen some that are actually direct projecting onto the retina, and some that, there was one example that was testing at 7 meters optically, but they tend to fall within the range of 40 to 70 centimeters, pretty broadly distributed across that range. We looked at 20 different studies, and I think we obviously, one of the things that will come out of this is that maybe in the future we want to have clearer guidance on how many studies we should be looking at for this, but that felt like a doable number for Siwan and I to work through. But yes, 40 to 70 centimeters, and I guess within that it might be somewhat dependent on, I guess you could say, for the hardware, but really no, we need to standardize it, because of course for nystagmus, you're going to be picking out a potential near null. So yeah, somewhere between 40 and 70. Okay, you've got the graph there. Yeah. And that's all just really to say on that. And then Siwan, if you want to jump in, feel free. But the as to the actual stabilization, it most used both a chin and a forehead rest. We found one example of using a bite bar. That seems excessive, and I think that was more on a physiological study of fixation. And in some cases, it just was unclear from the studies that we looked at whether how the head was stabilized. That was more about poor reporting than actual whether or not it was included with that. We don't know.
Okay.
So yeah.
As a group, would we be happy to specify a range of 40 to 70, but then put that little proviso in some conditions that could end up triggering something like a convergence null?
I would suggest we pick a distance. I'm only saying that the studies we looked at were somewhere between 40 and 70, but I think we need to be specific about that. So somewhere in the middle, 50, 60, etc. Yeah, I wouldn't want to give us a range, because obviously that has different results in different patients depending if they have nystagmus.
Okay, Amanda.
Is some of that because it's ease of working out what 1 degree is on the screen in terms of thinking about the distances that they've used, and a lot of that, like, yes, we've looked at 20 papers, but are they just because that's what's been used in their lab, and that's kind of, I guess the question I'm trying to ask is what would be best practice, right, as opposed to this is the range and we pick something. I guess I'm trying to look for what would be the best way to do this if we're designing it.
Okay.
Rebecca?
Muted.
I'm muted. I wouldn't mind Frank's opinion on this, because we perform our test at 1.2 meters. So, and that's just historical. But I wouldn't mind knowing why we're set up at that distance, actually. I would worry that I would just worry that you would be inducing a convergence null.
I think that's a really good point with nystagmus. If your whole point in this fixation protocol is you run it to detect fixation pathologies, and one of those pathologies you might be looking for is infantile nystagmus, and many people with infantile nystagmus have a convergence null, then you're absolutely right. And and another good reason for doing it a bit further away is, of course, if you have got we'll talk about the target detail later on, but if you have a detailed target and you have a presbyope, then they're going to potentially struggle at close distances as well. So on that basis, obviously we've done this literature review and we found this is what people have used on clinical populations in the past, but that is often because of the constraints determined by the manufacturer of the eye tracker or whatever they use in their lab. It's also sometimes a little impractical to put things at 1.2 meters just because you need a bigger screen then and so on. Just picking up on the point, the previous point about whether that affects the size of the target. No, we saw those as being separate things. So obviously, yes, if you move away from a screen, a 1 degree target gets smaller, but we would define the actual size of the target in degrees, and that's going to be the same regardless of your distance because you just change the size accordingly.
Right. So what I'm getting here is that we can't form an agreement on distance just yet. We're going to have to do a consensus exercise, I think, on that. So I don't know, Matt, do you want to try and formulate that? I guess that would have to come in a kind of, this is what we found, but
I guess perhaps, we can. Yeah. You've got this information that we've already produced on this. Maybe there's bound to be other points, right, that we can't just instantly decide here because everyone does it the same way. And so maybe we'll send out some kind of, maybe you could get a column for everyone to give their opinion on every one of those points of contention based on the evidence. And they fill in a table and we can then synthesize that at the next meeting. The point about the head stabilization hopefully is a lot clearer because for most groups it was a forehead and a chin rest. And then some said chin rest, but they might have maybe meant head rest as well. It's hard to know. That might have just been shorthand for forehead and chin rest. So I feel like that's a little bit more clear cut.
Yeah, I'd agree that's more clear. Rebecca?
Yeah, so just with the chin rest though, if you've got a head mounted piece of kit, that might become difficult.
Well, I suppose if it's head mounted, it doesn't matter because the point of the head stabilization is to eliminate head movements. But if your head mobilized, then that's fine. So
just something to think about that we probably would need to.
So in the event that it's a desktop mounted system, then you need some way of keeping the head still enough for that system. But of course, as technology changes, this is why ISCET needs to be reviewing these things. It may well be that the head stabilization may become less necessary. I know that the Tobii systems, for example, they claim that not to need head stabilization. I use the Tobii Spectrum, but I do use chin rest because I'm looking at fixation, and I feel like even though they say that it can deal with it on paper, it's nice to give the eye tracker the best chance it can have.
Okay, all right. So more or less an agreement on head stabilization for a desktop eye trackers, and then consensus of some sort. Exercise needs to be done regarding distance. Right. The next one.
Fiona's hand was up on the last point. I think.
Yeah, Fiona.
Yeah, thanks. Just very briefly, I think with head-mounted trackers, the main issue is slippage on the nose causing an offset. That's kind of a known problem with head-mounted eye trackers, and probably the best solutions for that have been the V-hit style trackers, where there's a very tight fit to try and avoid where you're doing quite fast head rotations, and that's really important to have the system stabilized to the head. But I think that with any other glasses that aren't these very tight rubber fits on the head, kind of like swimming goggles, that slippage on the nose is a known issue there, causing significant drift.
We'll have to note that. Right, so next one we have is room lighting, luminance effect on pupils, and that was Arthur and Fatima, both of whom can't be at their meeting today, but they gave a summary of the evidence and essentially suggested dark adapted conditions for eye tracking, which actually, if I think about most of the setups, it generally is a darkened room. Matt?
So darkened room is one thing. Dark adapted takes over, I think it's 52 minutes to dark adapt somebody. So that's obviously a big barrier if that's the suggestion. Oh, but this is using EOG. Okay, fair enough. Yeah, that changes things. Okay, so in that particular condition, I guess you would need to be, because you have the Arden index, don't you? Okay.
I guess we can just put the evidence out to the group and just see if there's any comments on that. But I think, yeah, Fiona?
I was just going to say that probably the stability of the environmental lighting is one of the most important aspects, that it's not changing during testing, because the pupil center can differ when it's adapting to light levels, and that would cause apparent movement that's not actually happening. And then just to say that with a lot of the newer eye trackers, head-mounted ones particularly, and bearing in mind, I think it was Larry who said that if there was a cheap eye tracker, it might be quite attractive. They differ quite a lot in terms of whether they have on-axis or off-axis illumination of the pupil, and that it dictates whether or not you get a bright pupil or a dark pupil. And actually, for those that look for a dark pupil, it could be that a darkened room would not be good for data quality, that it would have the opposite effect. So it's taking into account, modern eye trackers, especially head-mounted ones. It's not quite so straightforward which lighting condition would be optimal, and that probably needs to be decided based on the tracker itself.
Matt?
So I think there are two issues here. There's optimizing the conditions for data quality for any particular eye tracker, and there's optimizing the conditions to have a consistency of the way of the environment in which it's captured, so that a patient can move from one center to another and get comparable results. So and I don't see any reason, maybe there is actually, why fixational behavior would change based on the lighting conditions. If it is, I think we need to lean towards standardization of the lighting condition, so that the measurement comes out the same in both systems. And if it's the case that some eye trackers, a light pupil versus a dark pupil, and will give you a different measurement, then we would need to standardize that, I feel, because the most important thing here is that we can get this, that you can take a patient from one test center, move them to another test center, and get results that have been collected under the same conditions, essentially.
Fiona, were you coming back in on that?
Yeah, just very briefly. So the consistency of the lighting would be important, because, like I said, the center of the pupil can change and cause an apparent movement if the lighting conditions change and the pupil size responds to that. So I would almost argue that the consistency is more important than the light level. So you really don't want to be recording beside a window where a cloud passes over the sun and things like that, if you want to get fine movement reliably. And that's something that can't be corrected afterwards, whereas a lot of other factors could be if the light is consistent throughout testing.
Yeah, I'm just looking through it. They've provided some extracts from the audiology. Because there's standards for eye movement recordings and room lighting from the British Society of Audiology that we would need to consider. So they suggest complete darkness, but I think in the audiology test, sometimes there's spontaneous nystagmus that they're looking for as well.
I think that would have been true of the iLink and other systems. Yeah. So traditionally that might have been the case, but that's changing where you have off-axis lighting in a lot of newer eye trackers.
Yeah, it's just got to bear in mind that because we've already got a society that's issued their guidelines, if we're suddenly going to be contradicting those, it's going to cause clinical confusion. So we might need to look at that in context of what we are writing in this guideline and acknowledge existing guidelines. Larry? Yeah, you're on mute.
Right. There are a few neurological conditions where fixation stability depends on room lighting. Huntington's and Alzheimer's, both, you can see a difference in fixation and stability in a dark versus a well-lit room. That's only a minority of conditions what we're looking at, but that actually can affect what you're measuring.
Right.
You'll have to go shortly.
Okay,
Sorry,
so we are leaning towards another consensus exercise for that one. And then moving on, I think Sean and Mervyn have asked for extension on commenting on evidence for visual correction used or not, and binocular monocular recordings. Herman, and I think, are you on the call? Yeah, you are. You had to do shape of target detail.
Yes. So what I found is that sometimes it depends on what you like to measure. So when you have a very small target, crosshairs or something, then sometimes you get additional eye movement artifacts. So it depends on what you like to measure, I think.
Yeah.
So sometimes precise fixation is critical. So then you need a very precise target.
Okay. So Amanda, your hand was up. I don't know if it was relating to something earlier.
It was just for before. I'm kind of wondering, because a lot of these are dependent on the tracker that you're using and then the application itself. Obviously, we're trying to put together a fixation specific one, but I'm wondering if we have, for example, fixation, you'll need to be aware that room lights can affect this, and then be specific. I'm thinking about the structure that Matt had before. Be specific about what that lighting should be for the different things that you're looking at. So for example, if you're looking at nystagmus, we could all decide, okay, it's, you know, this particular type or that particular type. Or then if we're talking about some of the different neurological conditions being, you know, dark is how you should be testing this, or in phototropic lighting conditions is how you should be testing this. So I'm wondering if it should be specified there and being a little bit more generic here. Sorry, it was just a thought because it's come up on a couple of things in terms of being technology specific or condition specific. And yeah.
Okay. I think we were trying very hard not to be condition or technology specific in fixation. Developing fixation guideline was becoming quite tricky, isn't it? Fiona, quickly. Yeah. Fiona?
Yeah, sorry. So on the target, we had a study where we tested about 200 people on different targets to try and find what would be the most stable for previous data quality standardization work. So just if that's useful, we landed on a certain kind of target. And one of the just very practical issues that came up there is that the target should be an odd number of pixels wide so that you have a clear pixel that is the center of the target that you're calculating from. And that might not sound like it matters too much, but it depends on the resolution of the screen you're looking at. So that might be worth considering.
Okay, so we'll send that out for comment as well. So this was the next one. Oh, here we are. Size of the target. So this is for Tom and Gemma to do. I think we don't have Gemma, and I don't see Tom. But essentially, they come down to this. A target subtends around 1 degree of visual angle is commonly used, and then there's a description of smaller, larger targets may need to be used depending on the aim of the test. So again, we're coming down to if you're looking for certain things or certain conditions, you might need to enlarge the target so that they can actually see it. Okay, thanks, Larry. What do we think about the 1 degree? And then, oh yeah, Matt, yeah.
I just wanted to add the point that when we started this whole exercise, we said that there's a range of different ways of doing things that are all perfectly valid. And actually, in some cases, we just need to stick a flag in the sand and say that's what we're doing. That you know, and actually, any size will be fine because we say they all change fixation behavior. A large target will make people's fixation less precise. But if we're all using the same size, that's what matters most. So, so we don't need to go around in circles too many times. We definitely need to do this consensus exercise, but I just think we don't want to worry about, if we're all like, yeah, it's all fine, then we'll just pick something in the middle.
Yeah, so I think 1 degree is sensible, and then you just have to understand when you might need to change that. Next one. Oh yeah, I had fun with that. Location of target. I think that would be simple. But what I end up doing, because I was trying to be condition agnostic, what I decided to do was a search of all clinical studies that involved eye tracking to see where they put the target, just to look at where they put it and why. And basically, I would say central fixation is consistently used, but in some cases you might need to think about eccentric fixation when you're looking for particular things like gaze evoked nystagmus, or if you're looking for nulls and things like that. But central was basically where majority of studies landed. I think there was some where you don't use fixation at all, but so. Oh yeah, and I did see some VOR and things, and it gets complicated then when you're starting to get into HIT and things like that, because that's not, it's being used as part of the test, but is it actually assessing fixation? So oh yeah, and the problem with eccentric targets is that there's no standardized evidence-based protocol for number of targets, layout, range for those. So I thought I'd point that out. It was quite heterogeneous. I got every number under the sun, every angle under the sun, looking through all these studies.
Which is why we're doing this, right?
Yes. It was quite frustrating. Okay, so I guess we can just send that for comment, but I think central is the baseline for fixation assessment, and then take your pick of eccentric depending on what you need to look for after that.
I think this would be where we differentiate from a fixation protocol to nystagmus, right? So central, if you're just checking someone's fixation just as a quick one-shot thing, then central makes sense. And then if you suspect nystagmus, then that's what that protocol will tell us.
Yeah, and then if you think you've got someone with a weird acquired nystagmus, that you might need to go to eccentric because they could be a gaze evoked. But you should know that from your clinical indication. Right, next one was contrast of target screen. So Rasha and Jay did that, and you both came back to me separately. Jay came up with a very mathematical response to that. Let me see, where is it? There we go. You actually came back with C equals L max minus L min over L max plus L min.
Yeah. Yeah, so I did a bit of a trawl. As I said, I've come to it fresh really, because this isn't really my world. But that contrast sort of level basically came up repeatedly as a standard and was referenced by a large number of papers, hence all the references and stuff. There's a few nuances of certain contrasts being better for certain people, but generally, the reason I highlighted that oculomotor assessments, generally greater than 80 for that formula, seemed to be what made sense. So again, there's many people on this call who know way more about this than I do, but it seemed relatively definitive to my fairly basic trawl of the literature from people who'd actually commented on it, including studies looking at varying it and seeing what happens. But I'm sure others will have more useful comments on it than I.
Yeah, and then Rasha also gave a summary as well. Okay, we've got 5 minutes left for this meeting, so I think get some quick comments on that, and we'll see what's left on to go through, because I think majority of this will have to just go out for comments and consensus.
Yeah, but it would be interesting to know what other people do. But it seemed to me it was a fairly standard way of measuring it, and lots of reasons to not go below that level.
I thought it sounded sensible. And so Emma and Matt has got his thumbs up. All right, so we have, next we've got duration of testing. So Rebecca and Audrey did that. And you had the delight of going, it depends on the question.
Yeah, so I think Audrey's here as well, isn't she? We came at it from different angles, actually. So I came at it from the angle of, at what point do we get visual fatigue, you know, and therefore fixation degrades. So I did find a little bit of evidence, and it's sort of like between 5 and 30 seconds. And also I did find the guidelines for audiology as well, which, yeah, I think we do need to take that into account and acknowledge the fact that they're there. Audrey?
Yeah, so yeah, I guess I'm the one who wrote depends on the clinical question, because and it also depends then the duration of testing is very much linked to me to the duration of target presentation. So I was not quite sure how to answer this point before first having a consensus on the
What we're
previous
doing
point.
as well.
Yeah.
Yeah.
So
I think it relates, doesn't it, to what we decide we're doing as well. Jay?
Yeah, I'm struggling with this one a bit. Are we then talking about duration of overall eye tracking assessment, or are we talking about something more specific?
It's exactly the question I was having for Rebecca too. Like, so what do we mean by duration of testing, and like, do we also take into account then, I don't know, the patient positioning and if there is a calibration needed, like the time of the calibration and all of this. And
yeah, I would argue for this, you need something really simple. Like, there is some evidence that after 4 to 5 minutes of intense, eye tracking, fixations start to degrade. So overall, you want to try and do it for less than this time in an individual patient at an individual setting. I think going beyond that is going to be so unbelievably nuanced.
Yeah.
So having rather a maximum time rather than having recommendations for what is optimal, because that will depend. Yeah, I agree with
just
that.
a general principle to stop people trying to track people for 4 hours straight and expecting good data at the end of it.
I can't stare at a dot for that long. No. Okay. Next we had Onyeka about rest breaks, and then we also had, I think, Amanda on what to monitor during head posture. Those are the last two things. Onyeka, can you talk to yours quickly? And then I think I'm out of time, so I have a next meeting at 10. But
okay, yeah. So briefly, I think this follows on nicely from the previous one, which is about the duration. So studies that I found didn't really give specific time. Some of them mentioned rest breaks were given, and they could range from as little as 5 seconds to however the patient wanted. But overall, what they said was, or what I gathered from the studies, were that rest breaks were important because these tasks are could be quite demanding. And so in order not to get results that are spurious or not reliable, rest breaks are important. And then in between the rest breaks, it may be necessary to recalibrate the eye tracker to get good data. So that was a summary of what I got from the review.
yeah.
So Helena, just in the interest of time, I'd suggest that is just an additional line to what we just said about the previous one, isn't it? Rather than going any further.
And then last one, I think that's like what to monitor during testing. So I think Amanda could put quite a bit of detail on what she found.
I struggled a little bit with this because there's only a couple of papers that really tell you what they are specifically, but there's a few people have kind of written this is how we suggest you do eye tracking and how to do some of these measurements. So there's a range of pieces in there. The big ones were monitoring the data as it's going along. So I think that's quite common. I think Larry's kind of talked to that beforehand. So it's watching that quality of what's coming through. Watching for attention, so obviously with attention drifting off and then seeing a loss of nystagmus that's not really there, particularly thinking that might be a null when it's not, and then watching that it stays within the head tracking box. So thinking about the pupil reflection and the corneal reflection and pupil itself. So watching the tracking itself. I have written it down there. It is in a broader piece, but it could absolutely be summarized down to a couple of sentences. And I'll let it go there because it's 7 o'clock.
Okay. So we do have, we didn't get anything back from Frank about duration of target, but I think we know where this is going to be heading. It's overlapping a lot of the other comments that we've had. So what I'm going to suggest we do is that I guess Rebecca and I are going to have to just bring this down into kind of a consolidated document to go around for feedback and comments or something, and get the remaining bits from Frank, Mervyn, Sean, and then we should arrange a follow-up to discuss how we take this going forwards, because we are getting into a lot of depends on what you're looking for. So it depends on that starting question yet again.
Helena, shall you and I meet next week and try and consolidate? Yeah.
Try and consolidate this in some format that makes it easy enough for people to feedback on and comment on ahead of the next meeting, and then we'll schedule another meeting. Does that make sense?
Just suggest make it really clear when we're asking for feedback that we're talking about fixation and not nystagmus per se.
I'll highlight that. Yeah, because I kept drifting into nystagmus when I was looking into it, and I was like, no, it's fixation.
Yeah. Okay.
All right.
Thank you.
Thank you. Thanks.
Cool.
Bye.
Thanks.
Bye.
Bye. Bye.
Bye.